Welcome to Veera's classroom. In the series of problems we have seen in control system, the last video it was signal flow graph. So we have seen the basics of signal flow graph, how to convert a block diagram to a signal flow graph, and we have seen what is the formula that is being used to solve a control system into a simplified control system by using signal flow graph. The formula used to solve the signal flow graph is Mason's gain formula. In this video we are going to see the set of problems in the series of problems of signal flow graphs. We are going to see the first problem. The first problem is given here. Here they have asked us to find the overall transfer function of the system by using signal flow graph. They have given a signal flow graph and we are supposed to solve the signal flow graph and find a simplified transfer function. The procedure is different when you compare it with the block diagram reduction. In block diagram reduction we will be seeing how to move the summing point or the branch point from left to right or right to left, and we will solve the feedback loops, all those things. What is the major difference between block diagram reduction and signal flow graph is, in block diagram reduction the steps can be interchanged and you can vary the steps according to our need. So a block diagram reduction problem solved by two different persons will be different. The answers will be same, but the steps that they have followed will be different. But signal flow graph, it will be same for all the persons because they have a defined set of rules to be followed to solve the problem. So what are the rules? So what are the steps to be followed for solving this problem? The first step, to find a forward path. What does mean by a forward path? We have to find a path that leads from R of S to C of S. There might be only one forward path, or in some diagram we might have 2 to 3 forward paths. So if we have a path that's going to lead us from R of S to C of S, and that too they have a constraint here is you have to touch a node only once. So if it starts from node number 1 and it ends in node number 8, it should not touch the same node again. If it touches the same node 2 again and again, it's not a forward path. So we'll see what are the forward paths present in this diagram. The first, in all the problems of signal flow graph, we will have a straight line forward path that is common in all the problems. That is the straight line from R of S to C of S. That is 1, 2, 3, 4, 5, 6, 7, 8. So that's a straight line. That is the first forward path. And we can find that we have another forward path also, that is in the form of G6, that starts from node number 1 to, from 2 we have a loop that goes to 5, 6, 7, 8. So we have two forward paths. One is starts from 1 from node number 1, 1, 2, 3, 4, 5, 6, 7, 8, that is normal. And the second forward path that starts from 1 and leads to 2, from 2 it jumps to 5 and 6, 7, 8. So we have to write the gain of these two forward paths. How to write the gain of the forward path is, the signals that is present throughout this forward path will get multiplied, and that denotes the gain of the forward path. So we have defined two forward paths. The first forward path, that is from 1 to 8, we have just multiply all the terms, all the signals, that is 1 into G1, G1 into G2 into G3 into G4 into G5 into 1. So the gain of the first forward path will be G1, G2, G3, G4, G5. This is for first forward path. When you are going to see the second forward path, that starts from 1, goes to 2, jumps to 5 and 6, 7, 8. So when you are going to write the terms in this forward path, it is 1 into G6 into G4 into G5 into 1. So the gain of second forward path is G6, G4, G5, or else we can write it as G4, G5, G6. So the first step what I have said is, there are two forward paths, and the forward path 1, P1, I have drawn the diagram again, and forward path 2, P2, we have drawn the diagram again. So the gain of forward path 1, P1 is G1, G2, G3, G4, G5, and the forward path gain of forward path 2 is P2, G6, G4, G5. So step number 1 has been completed. We have found the forward paths. Step number 2, individual loop gain. So before going to find the individual loop gain, we have to know what is meant by loop gain. So what is mean by a loop? If you are going to start from one node, that is, we will consider we are starting from node number 2, If you can reach the node number 2 again, then it becomes a loop. So this type of flow diagram will be called as loop. So if you start from 1 and if you are going to end at 1, then it becomes a loop. So we'll see the major diagram, first diagram, and we'll check whether we have a loop. When we will have a loop, whenever there is a feedback element, we will have a loop. What is the feedback element? H, the representation H always denotes the feedback element. So when you are going to see the signal flow graph, you look for the feedback element H, and if there is a feedback element H, you will definitely having a loop. So here we have 3 feedback elements, H1, H2, H3. So most probably we will have 3 feedback loops. This is my assumption. We'll check it out. So in the first loop, that is H1, we'll consider H1. So it starts from node 3, goes through G2, goes to node 4. From node 4 it comes to node 3. So it is a individual loop. So if they are asked to find the gain of this individual loop, it is just a multiplication of G2 and that minus H1. So this is one individual loop. When you go to the second loop, that is 6 and 7, it starts from 6, goes to 7, comes back to 6. So it is individual loop 2. So it is multiplication of these two terms will give the gain of the second individual loop, that is G5 into minus H3. We'll see the third one. Third one is minus H2. It starts from node number 3, goes to 4, goes to 5 and comes back to 3. This is loop number 3. So it starts from 3, goes to 4, goes to 5 and comes back to 3. So when you are going to write the gain of this feedback individual loop gain, it's going to be G2, G3 into minus H2. We'll check it out whether we have only 3 feedback loops or more than that, because we had only 3 feedback elements and we have assumed that there are only 3 individual loop gain. As we assumed, here there are only 3 individual loops. There are 3 individual loops. We have named it as P11, P21 and P31. As I told you earlier, they have drawn the diagram again separately and they have given the loop gain for individual loops. P11 equal to minus G2 into H1, P21 equal to minus G2 G3 H2, P31 equal to minus G5 H3. So this is step number 2. First step is to find the forward path. Second step is to find the individual loop gain. Third step is to find the relation between these 3 individual loop gains. What kind of relation they will try to find is, they will find that whether the loop gains are touching each other or they have a common node in between those loop gains. If they have a common node, they will leave it as such. If they do not have a common node, they will be termed as non-touching loops. So we have 3 individual loops. By seeing the diagram itself, we can find that the first loop is starts from 3 and it has 4. So it has node number 3 and node number 4. The second loop has node number 3, 4, 5. So first loop and second loop will have common nodes 3 and 4. So we'll leave it as such. When you are going to compare the first loop and the third loop, the first loop has only 2 nodes, that is 3 and 4. The third loop has 2 nodes, that is 6 and 7. So there is no common loop at all, common nodes at all. So these 2 loops will be definitely be called as non-touching loops. Same way, similarly, the second individual loop is compared with the third one. The second individual loop has the nodes 3, 4, 5 and the third individual loop has the nodes 6 and 7. There is no common node. So these 2 are also can be called as non-touching loops. So while comparing these 3 individual loop gains, we can find out that there are 2 pairs of 2 non-touching loops. So that is P11 and P31 is first pair and P21 and P31 is the second pair. So gain product of 2 non-touching loops. There are 2 combinations of 2 non-touching loops. They are termed as P12, that is the first individual loop and the third one. P22 represents the second individual loop gain and the third one. So we'll just multiply these 2. So it is G2 in minus G2 H1 into minus G5 H3 and the P22 is minus G2 G3 H2 into minus G5 H3. So we have find the gain product of 2 non-touching loops. After this, we are supposed to find whether there are 3 non-touching loops, that is 3 different individual loop gains, and all the 3 do not have common nodes. So we have to find whether there are such individual loops which doesn't have a common node. We do not have such nodes, such loops here, because we have only 3, and out of 3, first 2 have a common node. So we do not have 3 non-touching, we add 2, so we'll stop it with this. So we'll go to the fourth step. If we have 3 non-touching loops, we'll proceed further. After getting 3 non-touching loops, we'll find for 4 and 5. It goes on. So based on the number of individual loops, this gain product of 2 non-touching loops, 3 non-touching loops, 4 non-touching loops is going to continue. But in most of the problems, it won't continue more than 3 non-touching loops. It will stop with 2 non-touching loops. So this one stops with 2 non-touching loops. We'll go to the step number 4. It is a calculation of del and del k. So what is del? So del, formula of del is 1 minus summation of individual loop gains plus summation of gain product of non-touching loops. So here the calculation goes from 1 minus p11 plus p21 plus p31 plus p12 plus p21. So the calculation of del and del k, the formula for del is 1 minus summation of individual loop gains plus summation of 2 non-touching individual loop gains. So based on the step number 2 and step number 3 data, we can substitute it here. It is 1 minus p11 plus p21 plus p31 plus p12 plus p22. The formula for del is going to be based on the problem, because in this problem we have only 2 non-touching loops, we do not have 3 non-touching loops, so the formula is simpler. If we have 3 non-touching loops, it's going to be again plus 3 non-touching loops, that's going to be summation of 3 non-touching loops, that's going to continue. In this problem it's simpler, so it is del minus, we'll substitute all those value of p11 and p21 and p31. So the substitution gives here 1 minus, open the bracket, it's minus g2h1 minus g2g3h2 minus g5h3 plus g2g5h1h3 plus g2g3g5h2h3. So when you are going to expand this term or multiply the minus sign inside, it's going to be 1 plus g2h1 plus g2g3h2 plus g5h3 plus g2g5h1h3 plus g2g3g5h2h3. So we have found the value of del. The last step is going to find the value of del k. What is mean by k? K is the number of forward paths. So initially we have told that we have only 2 forward paths, so k is equal to 2. So it's going to be del equal to k equal to 1 and 2. So it's going to be del 1 and del 2. So we have to find the value of del 1 and we have to find the value of del 2. So how they are going to find the value of del 1? So the formula for del 1 is 1 minus the individual loops that is not present in that forward path. I'll say it clearly. So del 1 represents the first forward path, the first forward path p1, and while checking p1 we have to check the individual loop gain also, and we have to find out of these 3 individual loops which individual loop is not having common node with this forward path. If you do not have a common node, with this forward path, that has to be considered in the del 1. So for forward path 1 we do not have any such things, all the individual loop gain have a common node with the forward path. So because the individual loop gain has 3, 4, 3, 4, 5, 6, 7, because the forward path 1 touches all the nodes, it has to be considered. So we'll go for forward path 2, del 2. We'll compare the forward path 2 with the individual loop gain. We'll have a non-touching loop. See here in the first one p11, that is starts from 3 goes to 4 and ends at 3. This individual loop can be drawn in this forward path without disturbing the forward path. So when you are going to write del 2, we'll write it as 1 minus this individual loop gain. So when you are going to write the formula for del 2, you see the formula for del 1 equal to 1, because there is no part of the graph which is not touching the first forward path, so it is 1. Del 2 is equal to 1 minus p11, because p11 is not touching this forward path. So p11, the value of p11 is g2h1 minus g2h1, so it has been del 2 equal to 1 plus g2h1. So we have found the value of del 1 and del 2. The last step is going to be substituting all those things in the Mason's gain formula. The Mason's gain formula is T equal to 1 by del summation k equal to 1 to 2 pk del k. So we will expand the summation. It is 1 by del into p1 del 1 plus p2 del 2. So we will substitute all those values. So substitute to the value of p1, it is g1, g2, g3, g4, g5. The value of del 1 is 1, so it is multiplied by 1. And the value of p2, that is g4, g5, g6, the value of del 2 is 1 plus g2h1. So it forms the numerator. The denominator is the value of del, which we found by substituting the individual loop gains and non-touching two non-touching individual loop gains. All those values has been substituted and we have found the value of del, that is to be substituted as the denominator, which is 1 plus g2h1 plus g2g3h2 plus g5h3 plus g2g5h1h3 plus g2g3g5h2h3. So the final answer is going to be g1 t is equal to, the transfer function t is equal to g1 g2 g3 g4 g5 plus g4 g5 g6 plus g2 g4 g5 g6 h1 whole divided by 1 plus g2 h1 plus g2 g3 h2 plus g5 h3 plus g2 g5 h1 h3 plus g2 g3 g5 h2 h3. So we have found the transfer function for this control system by using this signal flow graph. If you have followed the same problem by using block diagram, we will get the same answer. The answer will not be different for block diagram and signal flow graph, but what are the major thing is signal flow graph is much more easier than block diagram. There will not be any variation like what we see in block diagram reduction. With this we have completed the problem number 1. In the next video we will see the second problem of signal flow graph. If you like this video, like the video, comment, share and subscribe this channel. Thank you.